All right, in this video, we are going to complete the final exam review for grade 11 functions. Just a few questions left, so this one should not take more than 15 or 20 minutes. And if you did not watch the first part, which involves the first 52 questions, I will link that in the description and you can check that out. So question number 53, find the sum of the following series. So this over here, we can tell each term is going down by 8. So we can tell that this is an arithmetic series. We're going to use our general term equation to figure out the number of terms in this entire series. So I'm going to replace my Tn with my last term, which is negative 205. My A is my first term, which is 251. I'm trying to figure out my N, and my D is the common difference, which is negative 8. I'll subtract 251 on the other side, get negative 456. Then I'll divide both sides by negative 8, and I get 57 equals to N minus 1, and then I'll just add 1. So 58 equals to N. And then since I don't have enough space, I'm just going to solve the rest of this on another sheet over here. So now I need to find the sum of this entire series. I know there's 58 terms in it, so I'm trying to find S58. And this is just my sum of series for arithmetic equations, which is n over 2, 2a plus n minus 1 times d. Then I just have to calculate this. So that's 29. And I will just do that all in my calculator. Get positive 46. And then if I multiply that by 29, I just get the sum of the series to be 1334. Let's try it for part B. In part B, we can see that we're constantly multiplying the previous term by 3. So this is a geometric series over here. I'm going to use my general term equation to determine my n for this one again. I'll replace my Tn with negative 8748. My A is my first term, which is negative 4. My common ratio here, I'm multiplying by 3, so that's just 3. I'll divide by negative 4 on both sides. And then I want to make the two bases the same, so 3 to the power of, I'll do this as guess and check in my calculator. 3 to the power of 7 is 2187. So now the bases cancel. So 7 equals to n minus 1, which means that 8 equals to n. And now I have to find S8, the sum of the first 8 terms in the series. I'm using my geometric equation for this one. So that's A times r to the power of n minus 1 divided by r minus 1. Bottom is just 2. I'll do the top in my calculator. 65660. If I calculate this, I'll get the sum of this series to be negative 13120. So those are the two answers for question 53A and 53B. Question number 54, right? The first 4 terms of the recursive sequence. So we know the first term is negative 6. To find the second term, I'm going to use the recursive sequence. So the second term is just equal to 2 times the first term plus 3. So that's 2 times negative 6 plus 3, which is negative 9. So my next term here is just negative 9. Then my third term is just 2 times my second term plus 3, just 2 times negative 9 plus 3, which is minus 15. And then my fourth term, T4, it's just 2 times my third term plus 3, just 2 times minus 15 plus 3, which is minus 27. And those are the first four terms of that recursive series. Question number 55, determine a recursive formula here. So these are all constantly going up by 5, which makes this an arithmetic sequence over here. So I know the formula for arithmetic is T1 equals to A, comma, Tn equals Tn minus 1 plus D. So all I have to do is sub this all into this equation. I know my first term equals to 3. And then each term is just the previous term plus a common difference of 5 because it increases by 5. Question number 56, 57 are the Pascal's triangle, and I have exponent 4, exponent 5. So I'm going to show you an easy way to do this question. The first thing I'll do is I'll just draw out my triangle over here. I want to get to 5 rows for both parts in total. So that's my second row because that's a 2. This is my third row, my fourth row, and then my fifth row. Okay, so let's take a look at part A. For part A, my exponent is 4, so I'm using my fourth row of Pascal's triangle. I want to start by just writing the first term. Then you want to write the first term inside a bracket, and then you want to write the second term inside another bracket. Make sure you include the negative. I'm going to put the exponents later. So I'm going to follow this for all my coefficients. Just squeezed in there at the end. So once you fill out the coefficients and the terms like that, you want to fill your exponents. This is always a 4, and then it goes down by 1 each time. So it always starts at the exponent in the problem. And then the other exponent always starts at 0 and ends with the 1 in the problem. That's exponent 4 over there. So that's your first step, just basically setting it up like that. Second step is you want to distribute all the exponents into the bracket. So that's x8, that's just 1, that's, oops, 4, x6, and that's just negative 2y. That's x4, and then negative 2 squared is, so that's 4y squared. That's just x squared. That's negative 8y cubed. And then last term, that's just 1, and that's 16y4. So second step, distributing all the exponents into the bracket. Third and final step, we're just multiplying all the terms. So 1 times x8 times 1, it's just x8. Oops, that should be a minus. 4 times negative 2, so negative 8x6y plus 24x4y squared minus 32x squared y cubed, and then plus 16 Y 4. Okay, let's try part B. Same idea. I'm just using the last row over there. I'm going to just set it up with my coefficients. And this one I will do over 2 lines so that I have no trouble fitting it in one line. Do my exponents next. 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. Then I'll distribute all my exponents into my bracket. So 4 to the power of 5 is 1024 x5. It's just 1. 4 to the power of 4 is 256 x4, 2x cubed. 64x cubed, 4x6, 16x squared, 8x 9, 5, 4x, 16x 12, then 1, 1, 32x 15. And now let's multiply out all our terms. X4 times x3 is x7. And that is the final solution to this question. So that concludes the review completely. Like I said, not too many questions left. I just didn't have time to complete it the first time. But if you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.